Today we have a Yaesu FT-1000MP Mark V field here on the bench, and well, this radio is from our famous contest station, and the operators had the feeling that sometimes the receive is not as it should, and so it came in for maintenance, just to check if the receive sensitivity is given as it is mentioned in the specs on all bands and on both receivers, because we have a main receiver or a main VFO, and we have a sub VFO, and we have to check both to see if anything is wrong, to know what's going on with the radio. But first, this radio is with an integrated power supply, and so first, before we start any maintenance, we're gonna go for a safety test, because this is a class 1 unit, and therefore we have to check if everything is okay on the main power side, and if all connections are okay, and so forth. And after that we're gonna start our tests on receive. Yeah, I said before, this is a AC power supply, and this power supply does have a protective earth wire, which is also here in the main plug, and so we have to do some tests on safety with a dedicated tester, and well, let's start with our first test. Okay, just a short introduction to this safety tester. So this is a device which is dedicated to all devices which are movable. So therefore this tester does have some key functions, and these key functions are earthbound resistant measurement, insulation resistant measurement, substitute leakage current measurement, earth current and touch leakage current measurement, and well, that is basically what we gonna perform. So the first test is the earthbound resistance test, which is basically the protective earth wire within the cable to the radio, and therefore I have a special connector for 4-wire. It is a 4-wire resistance test, and we connect it first down here. Yeah, I hope we can see it, to the ground screw, and we have to set it to the test parameter, And what we can see is that we are reading a resistor of 0.07 ohm. And this is the first measurement, and our limit is 0.3 ohm. So that is the limit. It should not go higher, because if the resistor is higher, the protective function doesn't work, and so that is then really a danger. And well, the European rules is telling us that we have to check it in both directions, with plus 200 milliamps and with minus 200 milliamps, just to change the polarity. And in both directions it has to fulfill the requirements. So now when I switch it, we need to have the same reading, which we have, and we have indication lamps here. If the resistor would be higher than 0.3 ohm, this LED would lit and gives us the information that maybe something is wrong. Okay, so our Earthbound resistance test has passed, but well, the recommendation is to put it as well to another point, and I put it simply to our RF plug, and we should have the same reading, which we have, and I switch it again to change the polarity, and you see, so there is everything all okay. In terms of the Earth connection inside of the radio, so normally here we should have the same reading as well, and you see it has changed a little bit. Now it is 0.09, so you see there are some little differences inside, and but we are full in spec, so there is nothing to complain. But that is a reason that you should test the Earthbound connection at different points, and that is another point where we are back to 0.07. So we can be sure that our protective earth lead is good, and we are within all the specifications, so that is okay. Okay, our second test is the insulation resistance measurement, and what we expect is a resistor greater than a minimum 1 mega ohm with safety class 1 devices. And as we already know, our radio is a safety class 1, and we expect a resistor greater than 1 mega ohm. And our reading is, yeah, so that is infinity. So this is showing if the resistor is infinity. So we are putting on both main wires. We put 500 volt DC and measure the resistance between these two wires and the protective earth wire, and with this measurement we expect to have a resistor greater than 1 mega ohm, and we have, because our meter is reporting infinity, and there is no warning LED lit, so everything is good with this test, so radio has passed this test. Okay, we are now on the third test, which is a substitute leakage current measurement, and that is an alternative method which we can use if we would not use the insulation test, because as I said before, you put 500 volt DC to the radio, and if you have very sensitive components, you wouldn't do that, so you would then change to the alternative method, which is a substitute leakage current measurement. And well, with safety class 1 devices, which our radio is, because it has a protective earth lead, our limit is 3.5 milliamps, and we are reading 0.79. So that is definitely within the spec, but we see there is a LED lit, and that is normally a warning, so this indication is telling us the current is greater than 0.5 milliamp, and that is important, because if this radio would be a safety class 2, if it would be a safety class 2 device, then the reading must be below 0.5 milliamps, and then something would be wrong. But as this is a safety class 1 device, our reading is fully in spec, and I didn't expect something different, because our insulation test was already good, so that is fine, no problem at all. So, and our last safety test is the earth current and touch leakage current measurement, and therefore I have changed the plug from this test socket to this one, and this is more live socket, and that is what you can see here. The radio is on, right? And now we are testing for, as I said, earth current and touch leakage. And yeah, I turned down the AF. So okay. So there we have a limit of 3.5 milliamps again, and what we are reading is 0.45 under live conditions right now, and that is fully within the specs, and therefore I can say overall that the radio has passed completely the safety test, and we are sure that if something would be wrong within the power supply, all the fuses and RCIs and whatever is connected for safety reasons would work, and therefore we can say, okay, safety test passed, and we can go ahead with our maintenance and with our lab tests. So okay, let's start with testing. Power on, and I have chosen the 20-meter band, so let me change it to 20 meter, and I am at 14100, and what we can hear already, yeah, here is the tone. So let me just over the parameters. So we are coming back with 1016 Hertz, so that sounds good. So let us look for a signal to noise, which is 38, so we are feeding in minus 73 dBm, which represents 50 microvolt, which is S9. And yeah, what we can see here, so the radio is indicating S9, so that is pretty nice. And our bandwidth selector is on normal, so that should be something around 2.2 kilohertz bandwidth. But here it is indicated that we have an INRAD SSB filter, and I don't know this bandwidth, but anyway, in general it should be something around 2 kilohertz, I guess. So we are on the main VFO, and yeah, that is okay. So let us check the sensitivity, which is given in the specs. So therefore I have already made a copy. I put it better down here. So sensitivity, RX SSB on main RX, and this is a sub RX. So the sensitivity should be, it is both the same. So this is from 500 kilohertz up to 1.8 mega. So there we have a lower sensitivity, but from 1.8 up to 30 megahertz. So we have 0.16 microvolt, and it is measured with preamp on. So preamp on this unit is the Ipo Switch. Ipo stands for so Ipo stands for intercept point optimation. So with this button pushed, the amplifier, so the pre-amplifier in the front end, is switched off, and you can recognize it directly here on the S meter. So it is dropping down. So when I put Ipo back in service, you can see it is S9. So that is what is required in what it is required in this documentation. So okay, what I want to check again is, so we are 16 Hertz out of spec, which is more than good. But let me check the clarifier. Let me, it is on only, that is 10 Hertz, and now we have 20. Let me put it to 10 Hertz, and we can see now we are still 10 off. So let's go for another 10 Hertz. Yeah. So now it is nearly spot on. It's only 1 or 2 Hertz off, and our signal to noise is 41, which is great. But anyway, Yaesu is reporting it figures in a microvolt, so let's change it to microvolt. It is in dBm right now, and I'm gonna check it to microvolt. So you can see what I said before. Minus 73 dBm represents 50 microvolt, which is S9, so that is exactly what it should do. And now let's decrease the signal gen just to 0.16 microvolt, and we should reach 10 dB signal to noise. If that is given, the receiver is okay. And yeah, let's go down and let us observe our signal to noise, which is going down as well, which is right. Let us have a tone a little bit. So we are already at 0.3, and now we are at 10 dB more or less, and our sensitivity is 0.225, which is very, very close to what the specs are telling us. So I would not, yeah, it is already noisy. We can hear it here as well, so that is normal. Okay, let's check the sub VFO, what we have down there. Okay, with the band with selector to narrow 1, which is the idle condition, so switch on narrow 1 is switched on, and a bit smaller filter increases definitely the value for signal to noise, and therefore 0.198 is the right sensitivity value for the main VFO. So let us switch it to the sub VFO. So first of all we switch simply to dual. Now both are switched on, and okay, so the you may hear it. The sub VFO is coming in, and I disconnect now. Main and sub are both switched on, and I switch off the main, so main doesn't work anymore. Now it is only the sub which is working. I offset again 20 Hertz. And what we can see, the sub VFO seems to be a bit, these reflections here, I hate it. Yeah, sorry for that. So the sub seems to be a bit better, so we can reduce a little more, and 160 is pushing maybe a little bit more. Let's set it to 170, and there it is pushing for 10 dB signal to noise. So that means sub and main VFO are both very close to what the specs are telling us. So let us switch dual off and back in the main one, and the main one is a little bit less sensitive, but it is only a dip, and I think it is not really necessary to change anything, because in reality sensitivity on short wave do not say anything. At least it is more an indication, because everybody knows if we put a real shortwave antenna to the radio, then you recognize that the noise is coming up, and yeah, so therefore it is just an indication. It is just a lap value to get a feeling if the receiver is working in the right manner or not. Okay, but secondly, what I want to check is if the bandwidth is working in the right way. So therefore, let me increase. I go back to dBm because I'm more familiar to dBm, and I have a look, minus 122 dBm, so that is really a nice value. But anyway, let's go to S9, which is minus 73 dBm. So you can clearly hear it, and I switch off the speaker in here and I reduce it in here, and yeah, so we have really a nice signal to noise, and we have a real stable 1 kilohertz tone. But you know, we want to see what the level of the filter is. So the filter width, we want to check the filter width, and therefore I have here my my meter, and I have already adjusted it to 0 dB, so just a little bit fine-tuning it. let me put it on a 0. This not easy. Yeah, that is good enough. Okay, so that is 0 dB, and we know that all filter response are measured in the 3 dB range. So when the needle is dropping to 3 dB, so 1, 2, 3, so when the needle is on the 3 dB mark down here, so that is -5, so -4, and that is -3 dB, then the filter edge is reached. And that is what we want to see, because we want to know what is the filter width in this mode. Okay, so it is again S9, and now what I'm doing is I'm now changing the frequency to move the audio, so that is at least the audio. You know, I have already shown it in earlier videos. So this one is a 1 kilohertz, which we can hear in the speaker, and our radio is adjusted to 14.1 megahertz, and this is to 14.101, and this 1 kilohertz is our tone. So with 1 kilohertz, and the response is this here, so that is feedback, what is coming back from the radio, and you see it is really close to 1 kilohertz, and that is absolutely stable, nothing to complain, so that is really good. And now we have our 0 dB, so that is adjusted, and now I'm gonna change my value here, so it's looking like this, right? So that would mean right now 580 Hertz, right, which is now the audio signal, and you see that the sine frequency is moving on the screen as well, so that is what we want to check, okay? And we want to observe our dBm, not our dBm, sorry, our dB value. Once again, let me fine-tune it a little bit, because we want to do it as much accurate as possible. And now I gonna start. Oh, I have I just changed the frequency by accident, so that is not what we want to see. Okay, so now it is back with all the values we need. Maybe I lock it simply, because when it is locked I can't change it, so that might help a little bit. And okay, so let me once again change or fine-tune to 0. So yeah, so that is 0 right now, and we know when the needle is on the -3 dB value, then we know we have reached one edge of the filter. So I'm gonna start now to change the frequency down, first down to, let me switch on the speaker. No, that's too loud. Let's take this speaker. It is a little bit more convenient. So I start now to change the frequency down to 14.1, and let's see what happens to our dB meter. So okay, I'm starting. Maybe you hear the frequency, the tone, which is going down, and for the moment in time it is going up, our dB meter, which is okay. So we do not have a flat response, so that is normal, and we need to see where is our 3 dB point, and here we are. So that is really nice. So that is more or less our, the 3 dB point is somewhere in between. So that is -2, and here it is already -5. So we are down at 100 Hertz. So what we can say, the radio is able to receive tones of 100 Hertz. So that is what our frequency counter is reporting right here. Okay, and you can also see it here on the screen, and what you can see as well, I mean, yes, the sign is not as nice as before, but anyway, we are at 100 Hertz, so the radio is able to receive tones of 100 Hertz at lowest. And you see, so this is now -4.5, and if I only go one step higher, okay, only one step higher, it is already at minus, what is it, 2, yeah, a bit better. But anyway, what we can say is 100 Hertz gets received within our passband, or IF passband. Okay, so now back to 1 kilo. Let's go back to, that is already too high. So here we are back to 1 kilohertz. You see it right here, and you see a nice signal here, and again we are at 0 dB, and now we are cranking up the signal gen just to see where is the second edge, so for the high frequencies, and watch again our dB meter, and I will crank up our frequency, and you may hear the tone. It's going up, and yeah, now it starts dropping. Okay, so that is 2. So we can crank it up a bit more, and here we are very nicely at the 3 dB point. So that is the right edge, and what you can see here, it is 2.5. Let me take it down. So that is 2.5 kilohertz. So what does it mean? We start at the, let me say, left edge, whatever, of the filter with 100 Hertz, and we go up to 2.5 kilohertz. So we have a relatively flat response within this filter width, right? So that means the filter has a general width of 2.4 kilohertz in SSB, and that is what we basically expect an SSB filter with 2.4 kilohertz filter width is very nice, and we see where the 3 dB points are, and what we can say in general on the 20 meter band. Both our main and our sub VFO are sensitive as reported in the specs, and the filter width is 2.4 kilohertz with a relatively flat response over the complete bandwidth, so that is great. That is what we expect, and that is what we want to see, because then we know we are able to get all the frequency which were transmitted from distant end. We are able to receive it, and that is great. Okay, so that is the basic procedure which I will do now on all the different bands, because we need to know if all bands do show the same behavior. First, the sensitivity on main and sub, and then secondly, of course, we want to see where the filter edges are, to be sure that the radio is working in the expect manner. But I do not show all the different bands, because it is always the same procedure. I do now the complete performance test, and when I have checked all the different bands, I let you know if it is okay, or when I find one of the ham bands which might not be in spec, then I will show it. But if it is okay, you have seen the procedure, you know how it works, and I only let you know at the end of the day what the result of the test is. Okay, so I have finished my test on all the different ham bands, and what I can say so far, that the performance on all bands is almost equal. And what we can see here, I'm right now on the 10 meter band, and what we can see here is with 0.160 microvolt we are pushing for 10 dB SINET signal to noise. So that is what is marked out in the specs. So everything is good. So we have recognized that under some conditions under some conditions on some bands the main VFO is a little bit weaker than the sub VFO. So as here as well. So that is the main VFO, and when I change to the sub VFO, so you can see it is 1 dB better. So that is the situation on all the different bands. But there is one thing I didn't take into considerations when we watch again what Yaesu has written down here. Is condition is with preamp on, IDBT on, and under this condition we have 10 dB. So I'm back now to the main VFO, and we are pushing for 10 dB and with 0.160 microvolt, so that is 160 nanovolt, so that is really a small input level. So, but yeah, as I said, I didn't switch on the IDBT switch, which is this one here, and when I switch it on, it is indicated here, and with the IDBT we have a little improvement. So now it is off, and now it is switched on, and you see now it is peaking. Yeah, it is peaking 11.5, 11.7, whatever. So this is again an improvement of 1 dB. So IDTP is indicated with this little LED. So that makes a difference of about 1 dB. So that means, after all, that means the radio is fully in spec on all different bands. So the radio is pushing for 10 dB signal to noise on all the different ham bands, and that is really a good value. So what I can say so far is radio is on RX according the technical specifications, and it is working perfect, so nothing to complain, and there is no reason for doing an alignment or whatever. So this radio is going back to the contest group with the information that radio is fully okay. So that's it. No repair on this radio. So this was a performance check after all. And yeah, but anyway, hope that was a bit interesting as well, especially with showing the 3 dB points on the filter, which is inside the radio. I have shown the 3 dB point, so as well we can go and see the 50 dB point, and with the 3 and 50 dB point, or 6 and 60 dB point, it depends. You can calculate your shape factor, so but that is another story. This is just to see the flatness of the filter, and that was clearly obvious when we have done this test. So anyway, that's it. I hope you enjoyed it a bit, and if you like it, yeah, please thumbs up. Thank you. Catch you next time.